Okay, we're ready for Chapter 9, Section 3. Students will be able to solve quadratic functions by graphing. All right, the first key concept is just understanding what a quadratic function or quadratic equation is. In standard form, it's ax squared plus bx plus c equals 0, where a cannot equal 0. If a equals 0, that gets rid of your x squared term, and that leaves you with just a straight line equation, a linear equation. Okay, if you don't have a quadratic equation in standard form, you could get it in standard form by getting one side of the equation equal to 0. Okay, we've used factoring to solve a quadratic equation. We did that in the last chapter. And you can also use graphing, which we learned how to do in 9.2. Okay, so this is an example of the difference between factoring and graphing. Okay, we take the equation x squared minus 6x plus 5 equals 0. And we can factor that quadratic equation into the quantities x minus 1 times x minus 5 equals 0. And we know when we solve that, we set both of those quantities, separate quantities, equal to 0, and we end up with x equals 1 or x equals 5. And those are our solutions. Those are the two values of x that will give us a 0 for our y. Okay, so to solve by graphing, we would use our negative b over 2a to find the axis of symmetry and help us to graph the parabola. Okay, so if we take our negative b, we end up with a positive 6, and then the a is 1, so we have positive 6, and then 2 times 1 is 2. My computer is running very slow. When we reduce that, that equals 3. So our axis of symmetry is along the x equals 3 line. So I'm going to draw that in, my axis of symmetry right here. Okay? All right, now to find my vertex, I'm going to use that 3 and put it into the equation, into the quadratic equation. And I get 9 minus 18 plus 5. Okay? And 9 minus 18 is negative 9. And then negative 9 plus 5 is negative 4. So my vertex sits at 3, negative 4. So I'm going to plot my vertex. Sits right here at 3, negative 4. And then I'm going to go ahead and substitute in 2 and 1 to find points, and then I'll mirror those. So I'm going to substitute in 2 and 1. So if I put in 2, 2 squared is 4. Negative 6 times 4 is negative 6 times 2 is negative 12. And then plus 5. So 4 minus 12 is negative 8, and negative 8 plus 5 is negative 3. So I have 1 point that sits right here, and then the reflection of that would be right there. Okay, and then I'm going to take 1 and substitute 1 in, and I take 1 squared, which is 1. Negative 6 times 1 is just negative 6, and plus 5. Okay, 1 minus 6 is negative 5, and negative 5 plus 5 is 0. Well, we knew that. Seeing right here is we knew that 1 would be a solution. So 1, 0 is a point, and I reflect that, and looky there, I'm at 5, 0, which are my two solutions that I found while factoring. So just so you know today, graphing is an option to solve an equation. But if you can factor, that's the easier way to solve the equation and find the solution. So there will be my two solutions, 1 and 5. Again, same thing whether I graphed or whether I factored. Okay? Graphing is actually good for the equations that can't be factored, that don't factor and come out to weird answers. So just to show you can solve by factoring, solve by graphing, we ended up with the same solutions. All right, so just to show you a key concept 2 is number of solutions. A quadratic equation has 2 solutions if its graph, the parabola, has two x-intercepts. And right here showing you this one does have 2 x-intercepts. The parabola intersects the x-axis at 1 and 5, which are our solutions. Okay? A quadratic equation has 1 solution if its graph or parabola has 1 x-intercept. Now this would look like this. Okay? A graph or a parabola with 1 solution would have the vertex that sits right on the x-axis. So it only would have one point that sits right on the x-axis, so one x-intercept. So there would be your one solution, and it would be your minimum, or it could be your maximum if the parabola went downward. Okay, it could be the maximum. Either way, it has one solution. Okay, now a quadratic equation has no real solution if its graph has no x-intercepts, and that would look like this. If your vertex sat right up here and your parabola opened upward, it doesn't hit the x-intercept or x-axis. It never intersects it. Or it could have a vertex down here and open downward. Same concept. No solutions. In other words, there's nothing where the y is going to equal 0. Okay? Because that's what we're talking about here is a quadratic equation set equal to 0. There would be nothing that would make the y equal 0. So no solutions. Okay? All right, those are our key concepts. So our first example is determine whether the given value even is a solution of an equation. So here's my equation, 0 equals x squared minus 2x plus 15, and I want to see if 3 is a solution. So we want to know if we put in 3 for each of my x values, will it come out to be 0? So we're going to substitute 3 into the function. So I'm going to say 0 equals, and I'm going to put a question mark above it because I don't know if it equals 0. And I'm going to square 3 and get 9. And then negative 2 times 3 is negative 6 and plus 15. Okay? So 9 minus 6 is 3. And 3 plus 15 is 18. Now 18 does not equal 0. So therefore 3 is not a solution. Okay? So 3 is not a solution to that function. So stop the video, go ahead and do your guided practice for this. We're going to consider the function below and see if negative 4 is a solution. Okay, you should have had time to do your guided practice. What we're going to do is we're obviously going to substitute negative 4 in for each of our x values, and we're going to ask ourselves, does x squared, or negative 4 squared, which is 16, and then negative 6 times negative 4 is positive 24 and plus 8. Okay? So 16 plus 24 is 40, and 40 plus 8 is 48, and 0 does not equal 48. So 48 is not a solution, or negative 4 is not a solution. If it comes out equal to 0, it is a solution. If they come out equal, then it would be a solution. So negative 4 is not a solution. What about positive 4? You think positive 4 might be a solution? Let's try it. Just because I'm thinking, look how close we are. Let's try positive 4. Okay? Again, we have 0. Sorry, you don't know what I did here. Okay. We have 0. And we want to know if positive 4 would work. Will that equal? So 4 squared is 16. Negative 6 times positive 4 is negative 24 plus 8. Okay, so 16 minus 24 is negative 8. And negative 8 plus 8 is 0. So positive 4 is a solution. Okay? All right. Let's look at our next example. Example 2. Okay, it says use the graph to find the solutions of the given equation. So we're going to look at the graph of negative x squared plus 4 equals 0 to the right. So here's our graph. All we are going to do is we're going to look at the graph and find where the x-intercepts are. Okay, first of all, I want to point out a few things about this graph. It has a negative a, so it does open downward. It has no b, so it sits along the y-axis, or the y-axis as its axis of symmetry because there is no b. Okay, and it has a vertex of 0, 4, which you see right there, which is your C term, 0, 4. So here's your vertex. It is a maximum. The y values are all less than that. So look at the graph and find where our x-intercepts are. Well, one of the x-intercepts is right there, and the other one is right there. So now our x-intercepts, they are our solutions. They are the zeros of the function. They are all of those terms because those terms all mean the same thing. Okay? These are the solutions or the x-intercepts, the zeros of the function or the zeros of the function. This is supposed to say roots. This right here is supposed to say roots. So mark that out, please, and put roots. Okay, typo there. These are the solutions or the x-intercepts, the roots or the zeros of the function. All four of those terms are synonyms, and they mean the exact same thing. So, therefore, my solutions are -2 and +2. How easy is that to look at a graph and you can see if you can tell right where it intersects the x-axis? Okay, pretty easy? All right, let's go ahead and go to the back side of the paper and look at the next problem. Solve the equation and then graph it. Example 3. Now, it tells us to graph to solve, okay? But the first thing I have to do is I want to get this equal to 0. So I'm going to subtract 2 from both sides, and I get 2x squared minus 2 equals 0. Now, I can factor a GCF out of this, okay? And that would be 2. So let's go ahead and take a 2 out of this, and I'm left with x squared minus what? Okay, minus 1. Now, I have this 2 out here, this random 2. Doesn't affect my graph, doesn't affect my parabola. But what do I have in here? What do you notice this is? Hopefully you guys notice. It's the difference of squares. It's x squared minus 1. So I can factor, because that's what it says. We are actually going to factor first and solve that way. If your equation can be factored, factor it. Don't graph to solve it. It's too difficult. Okay? So I'm going to change this to x, or factor this to x plus 1, x minus 1. And now my 2, still again, my 2 is irrelevant to my solutions. I know that either x plus 1 equals 0, or I know that x minus 1 equals 0. So my solutions have to be x equals -1 and x equals +1. Okay? So now we're going to graph. Let's go ahead and graph. We've got 2 points. We have our x-intercepts. We know we're going to have a point right here, and we know we're going to have a point right here. And looking at this, what's my vertex? I don't have a b term. There's no x term or b. So this is my axis of symmetry. And where is my vertex? My vertex is at -2. Okay? So my parabola would go just like this. Except you would actually hit the point. Okay? So that's what our step 3 was right there. Plot the vertex and the 2 x-intercepts, and then graph your parabola. So your x-intercepts are your solutions, your roots, or your zeros of the function. Again, synonyms. Zeros, roots, if you're asked in your assignment today to find the solution, that's what you're doing, finding the x-intercepts. If you're asked to find the x-intercepts, you're finding the solutions. If you're asked to find the zeros of the function, you're finding the x-intercepts. So all of this works. I think you should be able to factor almost every part of your assignment today. Okay? Now, if you had a problem that said find the zeros or roots of the function, you'd follow the same steps as above because it means the same thing. If you can factor it, factor it. Then you could graph it. But find your solutions one way or the other. But most of your things in the assignment today, you can factor. I'm going to let you I'm going to stop the video, and you can do the daily homework quiz, and then we can solve this together or after you've done the homework quiz. And that can be factored, little hint. So find the solutions by factoring.